Last episode we built value objects, package size, package weight, local address. The compiler now stops you from swapping weight and width. That was the point. But we left something unfinished. Open Parcel Java and look at the status field. Private parcel status. It is mutable. No guards, anyone can do this. For example, here. The compiler is fine with all of it. Parcel status has a lifecycle, created, stored in locker, collected, but nothing in the code enforces that order. That is what we are fixing today with AggregateRoot. An AggregateRoot is the only object in a cluster that outside code is allowed to call directly. Parcel owns package size, package weight, tracking number, parcel status. They all have to be consistent with each order. A collected parcel can't go back to created. That rule has to live somewhere concentrate. 3 rules. 1. Outside code talks to the root only. Nobody reaches past parcel and modifies package size directly. 2. Business rules that keep the aggregate consistent live in the root, not in a service that might forget to call a validator in the object itself. 3. One aggregate, one transaction. You save the whole parcel or nothing. Let us build it. Before we touch parcel, let us look at what is already in common. This is the base for all our aggregate roots. Equals hashcode are based on getID from here. 2 parcel objects with the same parcel ID are equal, regardless of field values. That is identity-based equality, which is what you want for aggregate roots. Register event, this method is here, but we are leaving the calls out for now. Domain events are episode 6. The infrastructure is ready, we just won't wire it up today. Domain events. When we do that there, Spring Data reads this list after every save and publish whatever is in it. That is all that annotation does. For now, ignore it. When we do get there, Spring Data reads this list after every save and publishes whatever is in it. That is all that annotation does. For now, ignore it. Every aggregate root has to implement getID. That is how equals knows what to compare. Parcel returns parcel ID. Order returns order ID. If the domain events part doesn't fully click it, that is fine. We are covering domain events properly in episode 6. For now, just know the infrastructure is there and we are not using it yet. Okay, now we can add our BaseAggregateRoot to our parcel domain. So type extends BaseAggregateRoot and paste this ID, parcel ID. And now we can delete setter from here. Just implement method getID. So return parcel ID. Okay, extending BaseAggregateRoot give us identity-based equality and the event infrastructure for later. We also implement getID. So now our parcel status is the only non-final field. Everything else is set once at creation. That is the shape of this object, stable identity, controlled state transitions. So now let's create register method, public static, return parcel, and register. Now we can make this private, so we need to implement to create a parcel object. We need parcel ID, tracking number, package weight, package size, and create add set local datetime now. So we don't need a tracking number because we create this here, and local datetime now to create it also. Now we need make return new parcel, parcel ID, package weight, package size. Okay, it's all we need. Register is a business operation. It has a name. So if you make new parcel here, so doesn't tell you anything. So okay, we have created tracking number. Okay, no event call yet. That is episode 6. The factory method is still meaningful without it. Register says this is a business operation. Restore will say opposite. Let's make a change here. We make it like that now. And we register our parcel. Okay, we can quit this. And now make another function. So now we created another business function. Its name is pickup from sender. Our client put parcel to the our locker or courier take it from him. So now every transition method has the same structure. GUARD at the top, state update. I'm writing the GUARD. Oh, it's not equals parcel created. So throw new. Oh, throw new illegal state exception. So parcel must be created to be picked up. Got and plus parcel status. Okay, so yes, this GUARD is on the top. So now make state update. So parcel status picked up from the sender now. So I'm writing the GUARD every time rather than extracting it. Each method is explicit about what state it requires. So now let's create another business method, store in locker. So again, GUARD at the top. So this parcel status is not equal parcel status in transit to locker. So throw illegal state exception, parcel must be in transit to locker. Got parcel status. And now state update. If this gets called on a parcel that is indeed transit, it throws the aggregate root is the last place where this gets checked. So the status, parcel status stored in locker. Okay, now we created another business function. Its name collect. Terminal state on the happy path. Customer show up, enter the code, and took the parcel. So first, GUARD, this parcel status is not stored in locker. So throw new. Must be stored in locker. No, this parcel status collected. Okay, now we create another business function. Its name cancel. If this status is equals parcel status collected. So we cannot cancel if our parcel is taken. So draw parcel. Okay, cannot cancel a collected parcel. Nice. Okay, it's cancelled. Okay, now we create another name restore. Restore is different from register. Now, so it's public static, and return parcel. So we need parcel ID, package weight, package size. Okay, now we are loading state that already exists, so no guards. If register is the business operation, restore is the persistent operation. Okay, now we return new parcel package. Okay, nice. Okay, we make move this restore to the behind it. It's the same, but we need here parcel status now. Okay, it's good. Now we add parcel status here and put parcel status create. This it's register, but restore it's with parcel status like that. Here is the full life cycle we just built. Every arrow is a method with a guard. Collected and cancelled have not outgoing arrows. Terminal states. Before we move to the order domain, we need to implement serializable to the parcel ID. So, okay, now we can move to the order domain. Order is more interesting than parcel because one parcel always creates two orders, a sender order and a receiver order. Same parcel ID, different actors, different life cycles. We express that with a sealed class. So now we need to add BaseAggregateRoot. So type BaseAggregateRoot and type OrderId. Now remember to implement serializable. Okay, that's fine. So let's move to the sender order. And now we need to implement getID. We just implement it in the order. Now order ID, return order ID. That's fine. So now we can create in our sender order. Sender order need party ID from receiver and sender. So receiver ID and sender ID. Now can make private constructor and create static function sender order register. Copy from here and add deliver option. Like that. Okay, and now return new sender order. So order ID, parcel ID, saver, sender. Deliver option. We need to add deliver option to our order. So deliver option. Now this. Okay, nice. And here deliver option. Okay, and now we create business function assigned. So when the receiver gets a locker slot, we store the locker ID and pick up code on the order and move to assigned. Assigned. If the sender order status is not equal registered, throw new illegal state exception. Status must be registered to assigned. Got. Okay, and now we can make sender order status assigned. Okay, let's create another. Its name pickup. In the episode 6, we add events here. So let's back to the pickup. So if status is not equals assigned, so status must be assigned. Got status and update to pickup. Yes, and we add event here in episode 6. Episode 6. Now let's move to the our receiver order. So here we need to add this party ID. So receiver ID. We can copy from here. Okay. And deliver option. Okay. Doesn't make here. Let's create a register. Not like that. Parcel ID. You need to copy this. Okay, nice. Now let's create assigned business method. So, when our locker system assigns to the special locker slot, we create the system create pickup code. So pickup code. We need to implement the another variable in our receiver order. So private string pickup code. Okay, so if this status is not equals receiver not assigned and status is not equals not assigned but registered, throw new illegal state exception. Cannot assigned. Okay, now we can set pickup code and set status to assigned. Okay, now let's make another business function pickup. So pickup code. So if this status is not equal assigned, so true. Unassigned order. Now if pickup code is not equals, so first words pickup code is wrong. But if pickup code is right, so we set status to the picked up. Okay, nice. What is not aggregate root? Locker slot, not an aggregate root. It has no meaning without locker. Package private constructor, so only locker can create slots. The locker enforces one parcel plus slot inside. Async parcel. One aggregate, one transaction, slots included. Customer. We removed list order ID from it this week. It seemed like a natural thing to have, but every new order would have to modify customer to aggregates in one transaction, and the list grows forever with no business rule attached to it. That is a query, not domain state. Order repository find by receiver ID, and we paste party ID. Does the same job without touching an aggregate. Quick check when you are unsure. Does the object have invariance to protect across its own field? If yes, probably aggregate root. If it is coordinating other objects or just holding data, probably not. Now it's time to create ParcelJpaEntity. Split to the right. Okay. Now, what do we need? We need to JPA annotation, and JPA needs a no args constructor. So, no args constructor, args getter, and no setter. So, now we need parcel ID. This UI ID. So, we need to use annotation ID and generated value strategy type UID. So now we need tracking number. Tracking number is a string for now. So tracking number. Now we need package weight. So we have int values and unit. So we can use integer weight and unit. Unit has a symbol and name. We can create we cannot create a unit without a symbol or name, but we can use a symbol or a full name. We just use full name. So private string unit. Oh, sorry, wait need. Okay, we have package size, so we need private integer width, integer height, and private integer depth. And we need a private string size unit. Okay. Now we have created add, so private local date time created add, and we have the parcel status. So we can do it something like this. So parcel status and enumerated enum type string. So in database we can see created pickup from sender, not 0, 1, 2 at the 0. Okay, for this moment I think it's okay. It lazy loads collection on its own schedule. Put a notation entity on parcel, and JPA starts managing the aggregate's lifecycle. It gets to decide when things load, when things flash. The aggregate root loses control of its own state. This is a small cheat sheet, so if you don't know how to decide this domain is aggregate root, so ask this before deciding, and this is tips. Parcel, sender order, receiver order, local, party, all proper aggregates roots. Each owns its rules, each controls its state through name methods, each publishes events without knowing who handles them. Next episode, repository. Not JPA repository interface, a repository that speaks domain language and sits behind a port in the domain layer. Spring Modulith will verify the module boundaries hold. Code is on GitLab, branch part 3 aggregate root. Branch of it, try something different, open a merge request, I read them. See you next time.